or what is your previous technology you're working with?
MSB.
MSB, okay, you means you are already having the idea of SAP data warehousing. So let us brush up the skills, okay?
Yeah.
So here, what is a data warehouse actually? A data warehouse is a subject-oriented, integrated, non-volatile, time-variant collection of data in support of management system. So Bill Inman is a guy who is considered as the father of the data warehouse. Like a father of database, father of internet, okay, father of C++. Same lines, a father of data warehouse called as Bill Inman. He suggested this with respect to definition or 4 principles. So here, whatever the organization or whatever the tool it may be, all the tools are based on these 4 principles only in the back end, not from the front end point of view. So it suggests that whatever the data warehouse system you construct, okay, it should be based on these 4 principles. If it is constructed on these 4 principles, then all of the management requirements are getting satisfied. So what is the first one? Subject-oriented, integrated, non-volatile, and time-variant. So let us try to expand the definition. So go to, okay, so Bill Inman is considered the father of the data warehouse. Now, what is the first definition he told us? Subject-oriented, right? Subject-oriented. So you need to definitely focus on whatever I am telling, right? Because every day, for the first 15 minutes, question and answer session would be there. So whatever I have taught in the last class, I would be asking you the same questions. So you should be able to tell the answer. If you're telling the answer means you are understanding the subject.
Yeah.
Okay, yeah. Subject-oriented means, so usually, since you're already into OBAEE or MSBI, okay, we know how the data warehousing system works in the backend. So usually, we have different source systems. Okay, in the middle we have the ETL layer, and on the top we have the reporting layer. And your MSBI falls into this ETL plus reporting layer. Am I correct?
Yeah.
Okay, reporting layer. So this is how the data warehousing system would be working. So here, these different source systems are also called as OLTP systems, where the actual data is getting stored, the business data is getting stored, okay? And here, from this layer onwards, the data warehousing system starts. So here, my data warehousing system should have the capability to connect to different source systems, okay? And do store the data over here. And on top of it, we can have the reporting layer. So what my reporting layer will do, it will read the data from this layer and show in the reports. So what do I mean by your subject-oriented is, in subject-oriented, usually if you take any example of any organization, so here different departments would be there in every organization. So finance department, sales department, HR department, okay, materials management department, warehouse department. Like this n number of departments are there, okay, and these departments would be storing their respective data in one or either of the systems. So for example, the finance department is there. They are using Oracle apps as their ERP solution, okay, to store their data. The sales they are using Salesforce.com. The HR department is there. They are using peoplesoft.com. Okay, and one of the other department is there. They are using simple database. Some department XYZ is there. They are simple. They are just storing the data in their Excel sheets, simple files. Like this, different systems. I mean, different departments are storing their different data in different systems. So different heterogeneous systems. Okay, somebody are using ERP systems. Some departments are using some databases only. Some departments are using flat files only, which means here these departments are using different heterogeneous systems in order to store their respective data. And my data warehousing system, okay, so here my data warehousing system should be capable to, so here these different systems may be considered as different source systems. Okay, so maybe source system 1, So in the similar lines, source system 2, source system 3, which means different department is using different mode, right? So I am considering each one of them as one of the system. System 1, system 2, system 3, system 4. Subject oriented means my data warehousing system should be capable to connect to these different heterogeneous source systems. Here source systems are not connected to one another at all and totally different from one another. Even though heterogeneous means different, okay, but my data warehousing system should be able to connect to these different systems and read the data from, and that is called as subject oriented.
Yes.
Okay, so here that is next definition is integrated. Integrated means here these are the different systems where I am storing my data, and I am able to combine the data from these systems and write into the ETL layer. This is called as the subject oriented. But here the way the data is getting stored is a bit different. For example, what is today's date? 19th January 2015. Right? If somebody asks me to write today's date, so I'll write this way: 19.01.2015. Okay. Now, if I ask you to write, maybe you are writing in this particular fashion. So 19 hyphen, okay, or slash 01/2015. If I ask my friend, okay, he would be writing in the same fashion. So, okay, and if I ask any US citizen or a person working in US, then he would be writing the month as the first thing. Month as the first thing, then followed by date, then followed by year. So this is how the pattern would be. Okay, so like this. So if I ask some other person, then he would be something like this. 2015. Okay, here all are pointing to one and the same date only. That is nothing but 19th Jan 2014, 15. Sorry. But the way they are storing the data is a bit different. All are correct only. So nobody is wrong here. Okay. So here, assume the source system 1 is storing in this particular fashion. 2, 3, 4, 5. So different source systems are there, and they are storing their respective data in their own patterns, in their own naming conventions, in their own styles. Okay. In this case, what happens is, if you try to do the reporting on top of this layer, okay, each of them is considered the individual thing, not as a combined thing. Even though it's a format, okay, ultimate is 19th January 2015, but here the pattern is a bit different, right? So no two systems have the same kind of data format, right? So it will never combine the data and show you in a single report. So what do I mean by integration is, in the integration step, I need to convert my data according to my reporting requirement. Even though the data is same, okay, but the convention, the format is different, right? So here in this step, I need to integrate my data into a common format. So what I will do is, in this case is, assume, in our case, we are going to read the data from these 5 different areas. Then I will contact my respective manager and stating him that, boss, here we observed that the data has been changed. The date especially, is in different formats in different systems. So could you please suggest us one right format, what you want to see in the report? So assume we had gone with this particular format. So what I will do is, or what we will do is, we will convert the other 4 formats into this single format and load into the ETL. And this is with the ETL coming into picture. ETL, extract, transform and load. Extract means able to connect to different source systems. Transform means transform the data according to your reporting requirements. Here my reporting requirement is, I want to convert this particular set of data into this format. So we have some transformation techniques using which we will be manipulating our data or changing our data according to our reporting requirements, and finally load into the system. So this is what about integration. So Subject oriented means able to connect to different systems. Integrated means integrate or combine or transform your data according to your reporting requirements. Okay, and the third principle is non-volatile. Okay, non-volatile. What do I mean by non-volatile is data in the data warehouse should not be changed constantly. Okay, here volatile means changeable, non-volatile means non-changeable. I mean, yeah, just focus on the word. Data in the data warehouse should not be changed constantly, which means here we should not refresh our data warehousing solution data very constantly. Why? Because it is going to affect the reports, the output of the reports. For example, okay, I have a general body meeting tomorrow morning on 28th January 2015. Okay, the meeting is supposed to be attended by multiple big heads of the organization like CIO, CEO, okay, chairman, CFO, CTO, other different department managers, okay, are very high level people. Okay, and I need to present a report. So here in the report, when I execute the report today, so the meeting is supposed to from 9 a.m. to 6 p.m. for the entire day. So my presentation started at 10 a.m. So when I executed the report, I was supposed to show the what has happened during the past year, 2014, entire sales. Okay, so here when I was showing the report, it is showing me some data. Okay, that's fine. Now after 1 hour, I need to show the same report for some other different group of people, or I want to present the same report in a different fashion. In that case, if I am going on changing data in the back end, then my report figures, the values will be changeable in the front end, which means it may be misleading at some point of time. Okay, today morning it was some 10,000, now it has become some 13,000, so 3,000 change, right? So definitely the managers who wants to make a note of your marks which you are presenting, your reporting points, okay, definitely confused. Why? Because 3,000 margin, change in the margin with a span of just 2 hours. Okay, so definitely confusing, right? In order to remove this kind of confusion, what we will do is we will not update the data warehousing data not very constantly, not very frequently. According to the reporting requirement only, we are going to update the data. So what we will do is we will contact the business first thing, business management, ask them, boss, here it's in the data warehousing system, it's up to you to decide how frequently you want to update the data. Okay, so how frequently you are running your report, according to that only we are going to update the reporting requirements, update the data into your reporting. So he got up and told me that, hey Vinay, okay, we execute the what is called the report every day, every Monday, first week of the day only, and we'll never execute it on other days, for example, one of the requirements. In that case, there is no need of loading the data every day. What I will do is we will schedule a job which runs every day, every week at Sunday night or early days, early morning, early Monday morning, so that the data would be available for reporting by the time the manager reaches to the office. Okay, one of the manager has his requirement, something like every day he would be executing the report. In that case, what we will do? We will execute the report every day early morning, like 12 a.m. or 1 a.m. something like that, so that at the point of time none of the individuals would be updating the tables, right? So at that point of time we would be updating. So like this, we never change the data, even though used or not, in the data warehousing solution. It's totally based on your reporting requirements. We would be scheduling them, and that is the concept of non-volatile.
Okay.
Okay? And we have another thing called as time variant. Fourth principle. So here time variant stands for what Bill suggests is every data warehousing solution should and must support some kind of time-related activities, time-related features. What is the advantage of this one is the management can be able to analyze data from time point of view also. Why? Because here most of the management would be interested in understanding what is my calendar year-wise revenue, what is my sales trend happening with respect to year-wise. Okay, 2010 to 2015, how the sales trend is happening. Is the revenue increasing or is the revenue decreasing? Next, calendar month-wise revenue. Okay, so January revenue, February revenue, March revenue, December revenue. Okay, calendar quarter-wise revenue, calendar week-wise revenue, calendar day-wise revenue. Why? Because some of the companies are interested. So totally basing on the reporting requirements. But unfortunately, we never store the data with respect to only year, with respect to only month. We always store the data with a complete date format, complete day, single day format. Okay, we never store our data with respect to quarter. But my data warehousing solution should have the capability, should have some default time related activity characteristics, okay, which tells me about all of these things, which have these built-in features like year, month, calendar. So in that way, it may definitely help the management to analyze the data even from time point of view also. Okay, and that is about the concept called time variant. In this way, 4 principles are there: subject-oriented, integrated, non-volatile, and time variant. So if somebody asks you the definition of a data warehouse, your answer should be yes. A data warehouse is a subject-oriented, integrated, non-volatile, and time variant collection of data in support of management system. And also, you need to explain them what are all those things. Subject-oriented, able to connect to different heterogeneous systems. Integrated, integrate the data according to the reporting requirement. Non-volatile, data in the data warehouse should not be changed constantly or frequently. Time variant, able to support different time related features also. In this way, if you construct your data warehouse, okay, it would be definitely satisfying all the management's requirements.
Yeah.
Okay, so this is how
Yes,
the data warehousing system would be working on, and after the class, Srinivas will send you this kind of entire material, Shiva, site. So just go through the
Yes, sir.
documents and just go through documents and enhance your knowledge. So whatever I have explained, that's just the same thing is written over here. Okay. If you go to the definition of a data warehouse, simple. A data warehouse is a central repository for all or significant parts of the data that an enterprise's various business systems collect. So you can see, for example, I am working with an organization. Okay, my organization has different departments. Okay, so here these different. If I don't have the ERP, okay, enterprise resource planning system, okay, then definitely every department would be storing the data in different systems. Now, what my data warehousing system should do? Able to connect to those different systems, read the data from out there, integrate the data, okay, and put into my data warehousing solution. So here, my data warehousing system is exactly a single system only, not multiple systems. Okay, so that is the reason my data warehousing system is also called a central repository. So now, within the organization, if anybody wants to have some kind of reporting requirements, then you will never go and contact the individual department. No, you will come to my data warehousing solution and pull the data from over here. And no need to contact the individual persons now. Why? Because all of that individual department's data is combinedly stored in this data warehousing solution. Okay, no need to independently depend on those objects now. You can just directly simply contact the central repository. Okay, that is how it should be working on. And go to the second definition. Simple. A data warehouse is a copy of the transaction data specifically structured for querying and reporting. So here I am not doing any magic with my data. I am just pulling the data from the different source systems and writing into my data warehousing solution. So data warehousing systems are also called as target systems. Okay, here we have two types of systems: source systems, target systems. Source systems are nothing but where we are actually storing the data. Okay, data is getting stored, and we are pulling the data from these source systems and writing into a target system. So here I'm just reading the data as is from my source system and writing into my target system. But here the structures or the objects are defined in such a way that they are optimized for doing the reporting, for querying the data. Here these are not simply structured for storing the data, but for reporting, for doing the reporting activities. The same data is getting stored, but in different format. That's the only difference.
Yeah.
A collection of data designed to support a management decision making. Okay, and the data warehouses contain a wide variety of data that present a coherent picture of business conditions at a single point of time. So here I am able to combine the data from the different source systems and write in a single system that supports my management decision making. Okay, so that is how the different data warehousing systems will be work. And this is how a simple data warehousing system will look like. And whenever we look any data warehousing architecture or structure, it should be a bottom-up approach. Okay, at the bottom we have the different source systems, nothing but our operational data. Operation data means day-to-day transaction data. Okay, our operation data is available over here, and in the middle layer we have the data warehousing system. Okay, so your data warehousing system is built on the 4 principles which you have just discussed: subject oriented, integrated, constant or non-volatile, and time reference. And on top of it we have the reporting layer. So here sometimes this so this is the source systems, okay, ETL layer and the reporting layer. So the advantage of storing the data warehouse is okay, we can analyze the data in multiple angles, okay, in multiple ways depending upon the capability of your reporting system. So we can create the reports, we can go with the graphics, we can go with the tables. As you are aware, MSBI, so we can do n number of things with respect to the data. Okay, now done.
Yeah.
So before going ahead, we need to have a thorough understanding of what is this OLTP systems and what is this OLAP systems. Okay, so let us go to the notepad again and I will just try to explain over here. So what is OLTP systems?
Online transaction processing.
Online transaction processing. Okay,
Yeah.
transaction processing systems. So here OLTP systems, nothing but the place where we are going to store our day-to-day transactional data. So for example, take an example of a bank or any supermarket or any online store. So whenever you are ordering something, whenever you are doing a transaction, whenever you are purchasing something, all of the data is getting stored in the back-end systems. Okay, so those back-end systems can be anything. Okay, so usually the company would be using ERP applications in order to store their respective data. What do I mean by ERP applications? ERP systems. Okay, ERP stands for Enterprise Resource Planning. Enterprise means an organization. Resources means different resources like human manpower. Okay, the systems, the departments, all of each and every part of an organization is considered a resource. The machines, okay, and a plan. So within an organization, how we are planning your resources is nothing but an ERP system. Okay, so here if I have the ERP system, what is the advantage is here I no need to bother about multiple source systems. Here my ERP systems are designed in such a fashion, okay, that all of the data is getting stored over here without any problems in a single system. The backend systems are designed in that particular fashion. Okay? So let us take the example of any kind of ERPs. So do you have any idea of any ERP systems available in the market, current market as of now?
SAP.
Okay, SAP. Okay, very good. Next.
Oracle.
Oracle apps. Okay. Oracle is a so here I can go with the SAP ERP. SAP is a
Yeah.
company and ERP is product. Okay.
Product, yeah.
Same as Oracle is a company and the product name is apps.
Apps.
Okay. Next.
That's it, I think, yeah. I don't know whether MSBI supports ERP or not. I'm not sure of it.
No. Here I'm talking totally about source system. Your MSBA comes into data warehousing OLAP systems.
Okay.
Okay. So we have your own Microsoft Dynamics.
Oh.
Okay. So this is also an ERP system. Here, what is my intention? OLTP, the place where we are going to store our data, to store the day-to-day business transactions. Okay. Now, PeopleSoft,
It's okay.
HR system. Okay. JD Edwards.
Hmm.
Yeah, different organizations are using these different applications in order to store their respective data. Salesforce.com.
Yeah.
Okay. Bond.
Yeah. Well, yeah.
Like these a number of applications are there, but just I am listing out a few things over here. Okay, so these are the examples of the ERP applications used by most of the organizations in order to store their respective data. Okay,
Yeah.
and some people store the data in simple databases itself directly. Databases. So any examples from your side?
SQL Server, you're meaning that?
Okay. The world leader market, Oracle.
Yeah.
Oracle is one of the most biggest vendor in the databases. Okay. Now next Sybase,
Okay.
DB2, Teradata.
Teradata. Yeah.
Okay. MS Access also free of cost.
Yeah.
Okay. MySQL.
Yeah.
Like this, these are different databases also where usually the operations should be storing data. Sometimes we may go with simple files also to store our data, like Excel sheets.
Excel sheets.
Okay, and notepads, also called as .txt files.
Yeah.
Okay, so like this, normally they may be the OLTP systems may be ERP systems, or any kind of databases, or any kind of simple files also. So ultimately, the organizations would be storing the data in the respective systems. There may be anything. Okay, and all of these OLTP systems are based on the principles called ERM modeling. ERM stands for entity, relationship, modeling. Okay, so here entity means a table, relationship means a how the tables are related with one another and how do we model them.
Yeah.
Okay, even though these are the ERP systems, definitely there is a backend database to store the data, right?
Yeah.
In the front end they are ERP, okay, but in the back end they would be definitely using one or other database in order to store their data. So here which means whenever I talk about ERM or the OLTP systems, here always I am referring to tables concept only. Here in the back end tables would be there and they would be taking care of storing your data. So in the same fashion, we have multiple tables. Okay, in the same database we have multiple tables, and each and every table is connected to one another via the primary key foreign key relationship.
Yeah.
So that is how the entity things would be working on. So let us go with a simple table example. So for example, I have a table called the employee. Okay, in that employee table I have different fields: employee ID. Okay, employee name, employee employee what else? Age, for example. Okay, employee salary, something like this. And I am storing my data. For example, the employee ID is 1001. Okay, and employee name is Vinay. Employee age is some 30, okay, and the employee salary is some 20,000, for example. Okay, so these are the things are going on. Now, in the same fashion, I have another table, department table, where the organization is storing all the department-related information in this respective table, for example. Okay, it all. So as you are aware, every table should and must consist of a primary key, right?
Yeah.
So in this case, what is the primary key in the employee table?
Employee ID.
Employee ID. Okay. So in the department table, so department ID is the primary key. Okay.
Yeah.
And here the department name is there. Now department location is also there. Okay. Like this, we are going to store our data. Now go with an example. Department ID is a D1. Okay. And the department name is SAP BI, for example. And the department location is some Hyderabad, for example.
Okay.
Okay. Now, we know that every employee in an organization definitely belongs to one or other department.
Yeah.
Definitely. Okay. So now my manager has got a requirement. He told me that, hey Vinay, I want a list of a report which shows me, okay, which employee belongs to which department.
Mm-hmm.
This is one requirement. Also, he also wants to have a count of department-wise employees. So department 1, 60 employees. Department 2, 40 employees. Like count he wants to have. Okay. But if I observe, the employee details are stored in this one.
Yeah.
Okay. And the department data table, the department information is stored in this one. There is no connection between these two tables, right? And if I want to know which employee is working with which department, definitely I should have a common key. So here what we will do while designing the department table is we'll even include the employee ID also in this over here.
Yeah.
Okay. In that way, if I do here, what is this employee ID called in the employee table?
Primary key.
Primary key. And here, what is this department ID called in the department table?
It's the primary key for department.
Okay. And what is this employee ID called in the department table?
Foreign key.
Foreign key. Okay. Excellent. Because you have the basic knowledge, right? So you can just understand the concept in a very easy manner. Like this, with the help of this primary key foreign key relationships, we can able to establish a relationship between these two tables and able to pull the data. Okay. So here I have one common key between these two tables, that is called as employee ID, and it would be best or good enough if I have the common key as the primary key, because the primary keys are unique, right? So we would be having we would be getting the desired results according to our requirement.
Mm-hmm.
So then what I can do, because the connection has been established, right? Because the common key. Now employee ID, for example, 1001. Now basing on this employee ID, I can pull the data. So what I need to do? I need to write a select statement over here.
Yeah.
So you select. So for example, I want to pull the employee ID information. So I just want to pull a specific columns only. So column name, okay, employee ID, for example, employee name, okay, department name. I am not bothered about department ID.
Okay.
So these three columns, two columns from the employee table and one column from the department table. Okay.
Yeah.
So from these two tables, right, I need to pull out the table names also.
Employee.
Department. Yeah, what is my next step?
Join.
Okay. Before joining, here this employee ID is available in this table as well as in this table, right? So here just written employee ID. So confusion for the system.
Yeah.
From where I want to pull the data. So what I will do is for the table names I will give some alias names.
Alias name
E, comma D, and inform over here like please pull the employee ID from the employee table.
Yeah.
Employee name also from the employee table, and department name from the department. Okay, I'm just giving the alias names. Once it is done, now what we can do, we can write the where condition, join condition using the where box, where keyword. Okay, so where here for the employee I'm using alias key, right? So here what I can do, where employee table dot employee ID, okay, is equal to department table dot employee ID. So when I execute this query, what the system will do? Employee ID of where the employee ID is same, it is going to pull up the details, right? So here 1001, 1001 matching. Okay. Then what would be the output? The 1001 employee ID, what is the name? Vinay, and what is the department name? SAP BW. So these are the output would be working on. Okay. And here how it is possible? Because of this primary key foreign key. And we can write the statement something like this and pull the data from the respective two tables. So here all of your OLTP systems are working on the same principles in the back end. SAP ERP, okay, in the front end it is going to show you in the screens, but in the back end lots of tables are there, and the tables are connected with one another via the primary key foreign key relationship. And whenever you are saving the data, okay, whenever you are saving something, the data is going to store in the respective back end tables. The same logic applicable to all of the other things. Tables, and okay, every time tables are coming into picture, and these tables are connected with one another via the primary key foreign key relationships. So we can do the reporting on top of your OLTP systems also. No problem. This is nothing but your reporting, right? What is your reporting? Your reporting duty is to read the data from the respective tables and show in the output screen. Using the SQL statement also, I was able to achieve the same. Okay, which means we can do the reporting on top of OLTP systems also. But there is a lots of disadvantages or problems. Okay, so let us discuss what are those problems. So the first problem is here what I am doing over here, according to my requirement, I am writing this as SQL sentence and pulling the data from the respective tables and showing in the report table. That's fine. Tomorrow, one of the managers asked me to include some other details also in this query, in this report. Then definitely I need to I need to come back to this select statement, change the code accordingly and execute it. And here I am working with already existing one, which means I need to definitely take a permission, which means I need to definitely raise a ticket and approved by my respective manager. Okay, and if the code is a bit complex, a complexity is involved, then a lot of time is taken to analyze the code. Okay, and at the same time I need to thoroughly test it first thing. Then so usually I can't do it in the production system directly. I need to do the things in the development system, then move into the quality, then move into the production system. So lots of time is taken over here for a simple change also. A lengthy procedure needs to be involved for a simple change also. This is one of the drawbacks. I am not telling these are the problems. These are the drawbacks if you do the reporting on top of OLTP systems. Okay. So for every small change, a lengthy procedure is involved. First problem. Okay. And here these systems are optimized for writing the data into the database. Writing the data. That is the reason if you go to any store, for example, take the example of Big Bazaar or more supermarkets, every minute, the transactions are happening. So here somebody or other is standing in the billing section and they are storing the desk data, which means every minute thousands of transactions are happening throughout the branches of different branches. That is the reason, because of this optimization, even though thousands of transactions are happening every minute, my systems are capable of writing data in a very fast manner, which means the OLTP systems are write optimized systems, very fast in writing data into the respective database. But what are you doing by writing the select statement? You are trying to read the data, not write the data. Okay, which means the reading performance is degraded, because actually here, for example, I just saw you are you are just good at MSBI. If I right now give you the SAP BW work, then what you will do? If anything MSBI related, you do it in a very quick fashion. If I give SAP BW work, it will be taking some time, right? The same logic here also. Here actually the systems are right optimized, but you are reading, so definitely slower in performance. It will be doing the activity, no problem, okay, but slower in performance compared to writing. So this is the second drawback. The third drawback is, what is the actual purpose of these OLTP systems? To store the data. But what are you doing over here? You are reading the data. Okay, which means you are writing the data and you are reading the data on the same system, which means you are doing two activities at the same time, okay, on the same system, which means here you are wasting the resources. You are utilizing the same resources like your CPU, okay, hardware, the hard disk, the memory, the RAM, which means using the same system requirements, okay, you are doing two activities. So it definitely affects your writing performance. You are trying to pull the data, okay, you are trying to put the data, write the data using the same system resources. So definitely it would be going to affect their system performance. This is the third drawback. And here one other drawback is here always I need to write a select statement and pull the data over like this and show at the report level. No GUI supported. All the time it is capable to show the data only in terms of numbers only. Okay, but when it comes to my data warehousing solution, I can present data in terms of charts, in terms of some diagrams. Okay, everything is possible. But in the case of OLTP, you just can't do anything. You simply read the data and show in terms of numbers only. In terms of table format only, rows and columns, that's it. Not more than this. Okay? So, like this, these are the a few of the drawbacks of the OLTP systems. If you do the reporting, so for doing the business, excellent systems. But when it comes to reporting, okay, these are the drawbacks. So the managements are very happy by using these different applications in order to show the respective day-to-day transactional data. But when the management thought of taking the decisions based on this business data, they want to understand how the business is happening, okay, then in that case, these systems may not be useful for them. In order to overcome these problems, what we will do, we will go with another type of systems called as OLAP systems. OLAP systems. So what does that OLAP stands for? Online Analytical Processing. Nothing but our data warehousing solutions. Okay, and here we are so we know the examples of data warehousing solutions. So we have ETL tools as well as a reporting tool. So all of these tools are called as OLAP tools. Okay, so let us list out some ETL tools. So here if I go with the ETL tool, then SAP Informatica, for example. Any other examples?
Informatica. SAP BWS.
SAP BWS. Okay. Data stage. Okay. Here are the examples of the ETL. Now, when it comes to reporting, okay, then here the reporting SAP BW. Okay. So click you. Tab you. What else?
SSRS.
SSRS
sequence of reporting services.
Okay. TIPCO Spotfire. Okay, like this. Now there are few tools which can handle the ETL based reporting, right?
Reporting,
So is your tool does the same?
Sorry, which one?
Is your tool, I mean MSBA does the same?
Yeah.
Okay. So MSBA, then SAP BW,
Yeah.
okay, and OBAEE.
Yeah.
So these are the tools which can handle both of the things. So all
Okay.
of these tools are called as OLTPs, OLAP systems, and these
Yeah.
tools use a back-end architecture called as MDM, multi-dimensional modeling or star schema. Okay. Here, if you go to one of the definition of the data warehousing, I was telling you that a data warehousing is nothing but a copy of the transaction data, okay, which is specifically structured for querying and reporting. That's it, right? So if you go to one of the definition, a data warehouse is a copy of the transaction data specifically structured for querying and reporting.
Yeah.
Okay. What do I mean by this definition is here nothing but everybody is using some or other way to store the data. Here also the same tables concept. Okay, in the back end the data is getting stored in one other table. But here the way they are structured, that makes your reporting performance. That makes the reporting possible. And that is called as the star schema. Here in the star schema, I have some different tables called as a dimension tables. Here also the same table concept. Okay, dimension table. For example, I'll go with 1. Okay, so home, so dimension table 1, dimension table 2, dimension table 3, dimension. Okay, here dimension table 4. Okay, now just give it this gap and what is the center table?
Image.
Hmm?
A
You are
measure of
already
something. Oh, yeah.
fact table. Okay, here if you go to the definition, a data will is a copy of the transaction data. Okay, the same way here I am going to store the data, but specifically structured for querying and reporting. And this is a specific structure. So here we are going to store the data in this respective format, which makes my system a reporting tool. Okay, so here also the same concept, the tables, and the tables are connected with the, so here these tables are nothing but in earlier case, in the case of OLTP, the tables are connected with one another. Okay, employee table, the what is called the department table, the sales table, okay, the time table. That is different tables are there. In earlier case, the tables are connected with one another. Table 1 is connected to table 2, okay, where the primary key foreign key relationship, table 2 is connected to table 3, like this the things were happening. But in the case of the OLTP system, OLAP systems, the structure is a bit different. The tables are never connected with one another. No. The tables are connected with a common table called as a fact table.
Okay.
So here the primary key, for example, this is a table 1 as a primary key P1. Okay, this P1 is connected to the fact table. P2, P3, P4, which means here my fact table has the connection to the all the dimension tables over here accordingly. Okay,
Yeah.
and it also consists of, so it's nothing but okay connection where the primary keys, plus it also consists of key figures combination, key figures. Okay, so connection to all the tables plus your key figure values. So what is the advantage you are getting with this arrangement is you can analyze your data. For example, is the table 1. Okay, I have some 10 fields. Table 2 some 20 fields. Table 3 some 5 fields. Table 4 from some 5 fields. So 10 plus 20, 30 plus 5, 35 plus 5, 40. Okay, because all these tables are connected to this fact table, right? So with this arrangement, I can analyze my data without any changes from 40 angles, without any changes. No changes are required at all. Only this definition would be required. That way, one-time activity.
Yes.
Once it is done, okay, you can happily work on your reporting requirements without any issues. And that is the difference between the OLTP and OLAP system. Architecture point of view. In the case of OLTP, we were using ERM, Entity Relationship Model, which means in that case the tables are connected with one another. Here the tables are not connected. The tables are connected with a single table called as a fact table and they connect with one another via the fact table and makes your reporting positive. Okay. So all of the data warehousing services that are available in the market, whatever it may be, irrespective of the brand or vendor or whatever it may be, they would be using the same kind of architecture in the back end. That's the reason the star schema is coming into picture. Okay. We will learn a bit about these things in our next class.
Yeah.
Okay. So that is how the difference between the OLTP and OLAP system. So now, this is what the OLTP and the OLAP systems. This is one of the most important things we need to give. Why? Because if you go for any kind of interview, nobody would be directly asking you the tool related things. First of all, they would be asking you the generic questions of data warehousing. Once it is done, then they would be asking you the specific questions related to a tool. Okay? So we need to have a thorough understanding of what is this OLTP and what is this OLAP and all this stuff. Now, if we just combine, if we just go back to our basics, just now whatever we discussed about OLTP and OLAP, we can just apply the same thing over here. What is the OLTP stands for?
Online transaction processing.
OLAP?
Online analytical processing.
Analytical processing, okay. And what is the primary operation we do in the OLTP? Update the data, write the data and everything else. Okay. And what is the primary duty of an OLAP application? Analyze, read the data from the database. Okay. Next, here if you go to the option called relevancy of data, then we have current information in the OLTP, and in the OLAP we have current plus historical. What do I mean by this one? So take a simple example. For example, you went to a bank. Okay. So you asked them, hey, could you please provide me my statement of December 2014? Then what they will do? They will just give it in. Sir, excuse me, sir. Just wait for 1 minute. Meanwhile, tell me your account number. Okay. Once you are done with these things, they'll just give the statement right away in the next minute.
Yeah.
Okay. Tomorrow, go to the same bank and ask them to provide the statement of some Jan 2014, which is 1 year back.
Yeah.
Okay. In that case, if you ask, then what they will do is they'll ask you to write a letter.
Yeah.
And issue them and come back after 5 working days. They will never issue the same thing on the same day. No. Why? Why? Because here the respect data is not available in their current database, which is used to store the day-to-day transaction data. It is archived. So usually what organizations will do is that because every day thousands of customers would be visiting and doing the transaction, which means those respective data is getting stored in the back-end tables. Okay, every day thousands. Okay, every month some millions, and every year some billions of records are getting stored in the respective database. So definitely burden on the database tables, right? So what the organizations will do, okay, depending on their requirement, is they will archive the previous year's data, or they will archive every 1 year, or every 6 months, or every 2 years, depending on their business requirement, depending upon the amount of data they are getting. So they will prepare a similar kind of database, okay, in a similar environment, and put your past data into that particular database. And they would be having only the current information only, the current year or last 6 months information only in the current database. All the past data is archived. That is the reason If you go and ask the statement of previous month, no problem. Or anything below last 6 months, okay, no problem. They will issue without any problem within the next minute. But last 1 year or last 2 years, then what they will do? They will ask you to come back after five working days. Why? Because there's a lengthy procedure involved in the back end. These guys needs to go to the respective management team, take the permission over there to access the respective archive database. Okay, then put the query, then pull the data, take the report and submit it. A lengthy procedure is involved. That is the reason they would be taking it to permission. Okay, and here that is the reason my OLTP systems, depending on the business requirement, they will be storing some respective set of information only. But when it comes to reporting, OLAP, it is storing all the data, current plus historical. It needs to. Why? Because what is the intent of your OLAP system? To do the reporting, right? So, for example, here one of my managers asked me to generate a report which shows the sales trend from the last 5 years. Okay, which shows the sales trend from the day we started the organization. For example, we started the organization in the year 2005 and this is 2015. So which means my data warehousing system is having all of the entire data 2005 to the last 10 years of data. Okay, so that is how the data warehousing systems are very big systems with very big databases. Okay, spaces, very big RAMs, all this stuff, because it should have the capability to store the entire data of the organization as a whole. In the case of normal things, source systems, we are having different systems. But what is my data warehousing system? It's a single system which needs to be connected to these different source systems, read the data from over there, right? So which means my system would be very, very big, and it has the capability to store all of the data, current plus historical. And it should be definitely. Why? Because my intention is to do the reporting, which means to analyze data, the past data as well as the present data. Do you got this point, Sai?
Yeah, that's true.
Okay. Yeah. Now, here the data updates is often, as you are aware, every minute thousands of customers are doing the business, are doing the transaction. If you go to SBI, okay, State Bank of India, and then definitely every minute, okay, somebody is depositing the amount, somebody is withdrawing the amount, okay, somebody is drafting DD, demand draft, okay, check. Like this different transactions they are doing. It means very often the things are happening over there, very frequently. And in the case of OLAP, the things are what is called less frequent, only new data. Here, according to our reporting requirements only, we are updating it into the OLAP, not frequently, totally basing on your reporting requirement. For example, one of my manager executes a report, he just sees the data every Monday morning only. Then I will not update my data every day. No, I will update my data only on Sunday evening or Sunday night or Monday early morning only. Which means every 1 week only. Here it's totally basing on my reporting requirement. Whereas in the case of OLTP, it's totally business requirement. Every day, whenever the customer is purchasing something, definitely you need to store the data. That's the reason often. Okay, and here the database concept is complex in the OLTP and OLAP very, very simple. Why complex? Why? Because here lots of tables are involved. The tables are connected with one another by the primary key foreign key relationships and respective storage of the data. But when it comes to OLAP, here I am designing my objects according to my reporting requirements. For example, in my OLTP, there are close to some 100 tables. Okay, but in my OLAP, there are close to 10 tables only. Why? Because here I am not focusing on the entire data, okay, not the entire structures. I am just picking up only the relevant information for my reporting and putting into my OLAP system. That's the reason the things are very, very simple and small over here. But when it comes to my OLTP, it's like a very large system. complex system involved over there. You got this point, Sai?
Yeah.
Okay. Now here the number of transactions are many and few. So every time every number of transactions are users here, because different people would be involved in order to store the rest of the data, right? So to enter the data and click on the save button. But here only few people would be using my OLTP system. What was the managers only? No other people would be able to given the access to this particular system.
Yeah.
Only managers would be given the access, and they would be reading the data or doing the reporting according to their requirements. Okay. And when it comes to database data, here the things are normalized fashion, and the things in the OLAP, the things are denormalized fashion. Any idea of normalization, denormalization aside for you? No?
No, with that, I'm not able to exactly recalculate it actually.
Yeah, sure. Okay, so I'll just explain it with an example.
Yeah.
So your normalization means, so here, who is the father of the data warehousing?
Sorry.
Billion. Okay, in the similar lines, we have the father of the data warehouse.
Yeah.
His name is EF. Okay, so Bill Inman suggested 4 principles, right, in the construction of a data warehouse. In the similar lines, EF suggested some 12 principles in the construction of a data warehouse, databases. Okay, so he has suggested some 12 principles. Out of those 12 principles, one of the principles is normalization. So what he suggests is, for example, I have a table called employee. Okay, I have a table called employee. So employee ID, okay, employee first name, employee last name, okay, employee surname, employee age, okay, now employee qualification, okay, employee skill set, okay, what else? Employee project name, okay, employee project manager, employee delivery manager, okay, now employee working location, okay, next employee salary, employee PF, okay, something details are there.
Yeah.
Now what Bill Inman suggests is, instead of whenever split these kind of large tables into small tables. So instead of storing all of the employee details into one single table, split the table according to your requirement. So here, these are nothing but the employee basic information. Okay, these are nothing but the employee project related information. Okay, and these are nothing but employee salary information. So instead of going with these clubbing of all of the entity into a single table, split these large tables into small tables. Okay, so go with the option called employee basic and split it. Okay, so till this point of time, for example. Now, employee project. Okay, employee project. The table name employee project. Okay, and put the employee ID here also again.
Yeah.
So now till this point of time, next employee salary. Employee salary, put this employee ID over here. So like this, just try to split the large tables into small tables. Why? Because the advantage you are getting is, for example, employee wants to store the respective data. He has changed the project. Okay, he has changed the project. Then instead of working with all the other irrelevant objects also, okay, you can work with only the objects which you want to change. You can directly contact this employee table, project table, and what is called, change the entity data over here according to your requirement. For example, the employee salary got changed. So contact this table only. No need to bother about other information.
Yeah.
So this way, the writing of the data would be becoming very, very fast. Why? Because you are contacting the, for example, we have some 3 different rooms in our house. Okay, kitchen, okay, hall, some study room. So you want to go to the, you want to go and eat something. So where do you go? Directly to the kitchen.
Kitchen, yeah.
Okay, you want to go to the study. You want to get a book. So directly go to the study room. The same logic applied over here. Instead of searching for all of the objects, what field I need to update, okay, here directly you are showing the relevant information, the relevant tables, right? So it is going to go in the back end. It is very easy for the system to write the data, okay, and this is called as normalization. So splitting up of very large tables into small tables is called as normalization. But when we do the reporting on top of this one, it is some problem. Why? Because, for example, I want to find out employee name, okay, and employee project name and employee salary, for example. It means these 3 information is available in 3 tables, right? So what I need to do?
Join.
So select. So employee name, right? So employee first name, okay. Next, employee project name, right? So copy.
Yeah.
Next, followed by employee salary, right? So copy. Okay. Next, from statement I need to write. From employee basic.
Basic.
Okay. So this is the first table I need to figure out data for. I am giving alias name as A.
Yeah.
Then employee project. B, employee salary. C, okay.
Yeah.
So A dot
Dot.
B dot
B dot C
C
dot.
dot. Okay. Now I enter a where condition. Where A dot employee, because in all of the tables employee is the common key, right? So A dot employee ID is equal to B dot employee ID is equal to C dot employee. Okay. So here, if I execute this one, then first this condition should be reached. Then this condition. Okay. Like this, it should satisfy the multiple conditions. Then only you can see the output to the answer.
Yes.
Which means here, if the number of joins are increasing, okay, number of joins are increasing, the complexity is also increasing. Okay, the reporting runtime would also be increased.
Yeah.
That is the reason this kind of pattern may not be suitable for doing the reporting. It is suitable for writing data, but not for reading the data. That is the reason what we will do. Instead of maintaining the data in multiple tables, go with individual table. Combine the data, okay. Combine all the fields, because for all the fields employed is the common key, right? So combine all the fields and combine into a single table. In that way, no need to write the entire join, no problem at all. Okay, so exactly one table only. No need to write the entire join. So simply reading it from a single table. So no joins are there, right? So reading of data would be very fast. And this is called as denormalization.
Denormalization. Okay.
Normalization means split a large table into very small tables.
Yeah.
Denormalization means okay, combine small tables into one large.
Yeah.
Okay, and that is how the principles are working over here. The normalization and denormalization. Okay, so that is the main difference between the OLTP and OLAP. Somebody asked me the same question, or if somebody asked me the same question, my answer would be, so definitely if you go for any interview, this is one of the most common interview questions in every. OLTP stands for Online Transaction Processing. OLAP, Online Analytical Processing. OLTP systems is based on ERM modeling, Entity Relationship Modeling. OLAP, MDM or star schema, multidimensional modeling or star schema.
Yeah.
OLTP systems are optimized for writing the data. OLTP systems, OLAP are optimized for reading the data. Okay. Here the number
Yeah.
of views are many. The number of views are very small sum. Here the database concept is a bit complex because the number of tables involved and the law and the connectivity involved. In the case of OLAP, okay, that's it. The things are very simple. OLTP contains current year information only. OLAP contains current plus historical. OLTP is in normalized fashion. OLTP is in denormalized fashion. Like this, you need to always talk in terms of data warehousing terminology. Okay, you need to use some keywords like this, and no need to tell them the entire story. Okay, no need to tell them just 4 to 5 differences. That would be more than enough. And you should be also able to explain them with an example. In that way, we can just satisfy your interviewers' answers.
Yeah.
Okay, so that is the difference between OLTP and OLAP. And this is, as you are aware, any data warehousing system will look like. So here, the different. So as I was telling you, in the case of a data warehousing solution, we have different source systems. It can be any, one or many, but exactly one data warehousing solution, and on top of it, we have the reporting. So you have the different data sources. Okay, they can be anything. They can be SAP ERP systems, files or non-SAP or whatever it may be. Okay, and here this is my BW server, nothing but my ETL layer, and this is my reporting layer. And whenever I talk about SAP BW, to be specific, okay, my primary source system would be SAP ERP system, because SAP ERP is also a type of OLTP system. So whatever the drawbacks we have discussed just now, okay, are all applicable to SAP ERP also. So in order to overcome that particular problem, the SAP has come up with its own data warehousing solution called SAP BW, and SAP BW itself is a ETL system plus reporting system, which means all the ETL activities are handled in the SAP BW server, and all the reporting activities, we have a tool called the Business Explorer.
Yeah.
Okay, so in this tool we are going to do the reporting activities, and this is how your backend architecture of the SAP BW given by SAP. So as I already told you, whenever we talk about any SAP BW, any data warehousing architecture, it should be a bottom-up approach. So in the bottom we have different systems, source systems. Okay,
Yeah.
There can be SAP applications or non-SAP applications. Whenever I talk about SAP applications, they can be anything, like your SAP ERP. SAP ERP is also called as SAP ECC, Enterprise Central Component. Okay, and SAP CRM systems, SAP SRM systems, anything. Whatever the things that are manufactured by SAP, and they are used to store the respective data. And when it comes to non-SAP system, anything except SAP, any kind of databases or any kind of systems, non-SAP. Okay, and here this is nothing but my BWBI layer. So here I will be connecting to these different source systems. Okay, reading the data from over here and writing into these different objects in the BW. And this is what we are going to learn in our practical classes. So PSA, ODS, which InfoQ, master data. So these are the places where we are going to store our data in the BW. Now, once it is available over here, okay, we can do the report. So third part, Business Explorer. So we have the OLAP processor in it. It is like a CPU. It is like a communicator between my reporting layer and the ETL layer. So using the Business Explorer, I would be satisfying my reporting requirements. So this picture is right now very confusing, and I know. So once we start the practical classes, I'll come back to this picture again and show you what we have studied. What we have studied and how the things are connected with one another. I'll get back to you again to this picture. As of for now, just keep this picture in your mind.
Sure. Yeah.
No worry if you don't understand also. We'll come back to it again at a later point of time. Okay. So we'll continue from here onwards, Sai.
Yes, yes, sure.
Tomorrow at the same time, 6 a.m. our time.
Yeah, yeah, sure. Yeah. Yeah.
Any
Thanks,
questions
man.
for the day side?
No, 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 no. I'm fine for the day.
Correct. So Srinivas will share you this kind of documents. I'll just share with you, and once
Yeah.
you're done, just go to the document which you have referred to. Meanwhile, what
Sure.
you do is, if you have time, go to Google. We have luckily Google, right? So go and type over there OLTP versus OLAP. 4 principles of data warehousing. Just try to enhance your knowledge by reading multiple links over there.
Yeah.
Okay. In
Sure.
that way,
Yeah.
you
Yeah.
can have a strong knowledge, strong foundation of the data warehousing.
Yeah.
Okay.
Yeah.
Okay, then
Okay.
we'll catch you tomorrow at the same time.
Yeah. Yeah. Sure. Bye bye.